Hello, everyone. In this video, I will give a guide and tips for chapter 10 of my Java book. Chapter 10 is on object-oriented thinking. So before chapter 9, we introduced procedural-oriented programming. You learned the basics in programming, learned writing programming using loops, using methods. You can do a lot of things with loops and methods and using arrays. But using object-oriented programming, you can develop reusable code. You can develop large systems and using reusable code. So making software development more efficient. So this is the introduction. And the next section is on class abstraction and encapsulation. Class abstraction is separation of class implementation from the use of class. The details of implementation are encapsulated and hidden from the user. So this is known as class encapsulation. So here we look at how we design the object-oriented system, design classes to model objects. So this is the for the user of the class, all you need to know is the contract of the class. And the implementation is like in the black box, it's hidden from the user. But as the design of the class, and you're going to implement inside the class and implement all these data fields, constructors, and methods. Now, we use this example, the loan. We have done a lot of exercise involving loans and interest rate. And here we use object-oriented approach to design a class named loan to model all the loan objects. So we have all these data fields for loan. In loan object, you have the annual interest rate, number of years, and loan amount, and loan date, the date the loan was created, and the constructors, and all the appropriate methods. So this is the design, and here, now as a user of the class, provided the class is implemented, and from this design, the UML, and you know everything about the class, you can write a test code using the class. And as the implementer, so you write the implementation for the class. So this is the important pedagogic tip. So use the UML diagram for the loan class to write a test program that uses the loan class even though you don't know how the loan class is implemented. So this has 3 benefits. First, it demonstrates that developing a class and using a class are 2 separate tasks. It enables you to skip the complex implementation of certain classes without interrupting the sequence of the book. It is easier to learn how to implement a class if you are familiar with it by using the class. So thinking in objects, and we get into another example we have done in the past is the BMI, computing the BMI. So instead coding everything in the main method, and we develop a class for BMI. So with the name, age, weight, and height, and for the BMI. So constructing the BMI objects. And so this is a get BMI and get status. So this is to use the BMI class, and this is to actually writing the implementation for the BMI class. And here in this section, we discuss the class relationships. So how you design classes in object-oriented systems, the objects are related. So their corresponding classes are related. We're going to design it and the relationship. So let's look at the association relationship, aggregation relationship, and the composition relationship, and how you design the classes and find out the relationship among the classes, and then implement the classes. So here's the example of designing course class. So we have a course student taking the course. So course has a name. So this is the name as a data field, and this is all the students taking the course. And here we have the number of students that track the number of students in the course. So the constructor and the methods here for the course class. And there's another design example is to design a class for stack. So we have here is a stack of integers. So this is, we're going to store and all the integer elements in the array. And this is the size to track a number of elements in the stack. So here the constructor and the methods for the stack is empty, peek, push, pop, and get size. So this is writing a test program code and then writing the implementation for the stack class. All right, so we're going to look at the all this primitive data type in Java. They have corresponding wrapper classes. And so you can construct objects for primitive data types. So this is here for the, so we have the, for int, we have integer. For double, we have double. See the spelling, this is all the uppercase for double. And so those are the, for the, all this primitive data types we have, for each, we have a corresponding wrapper class. So in Java, there's an automatic conversion between primitive data type and wrapper class. In the context, the compiler automatically recognizes it. So, and so here's example here is you have this, the integer. So here we created an integer object. So this is the integer, okay, and this is the one is automatic. You assign the primitive data type value 2 into an integer object. So this is automatically boxed into an integer object. And this one here, so look, you have this integer value 2 is assigned to x, that's fine. But if you have this is an integer object assigned to int, and this is automatically converted it into a value 2. So it's the same as this. So this is here. All right, so this is the auto conversion between primitive data type and wrapper class. All right, so we have what happens if you have a very large integer. So you cannot use int or long, and you can use big integer. So if you want to have very high precision for decimal numbers, you can use big decimal in this section, the big integer and big decimal classes. So in this chapter, we look at the string class. We already introduced the string class in chapter 4. So we'll take a deep look at this string class and look at more features in the string class. Just remember the string class now, it's immutable. String objects are immutable. So there's all these features about the string. So this is and what is intent string? So this is very unique in Java, is when you create a string and using the literal value, so that string object is called intent. And intent string objects can be shared. So because they are all the same. So like here, you have welcome to Java, and this is welcome to Java here in S3. So they are created using the string literal. So this is the same object. It's called intent object. It's different from you're creating new string using this new string and welcome to Java. So we have other methods for string, replacing, splitting. So please remember that string is immutable. So when you replace it, you're not actually replace the content of string object, but you're returning a new string with the replaced contents. So here, all this replace, split. And this is matching, replacing, and splitting by pattern using regx. So it's regular expression. And this is very important for your task to process string. It's very powerful technique. So you can learn more and go into the appendix H. Converting between strings and array, you can convert the array of characters into a string and also get a string into array of characters. So this is here. And this is converting characters and numeric values. And so using this is that you have this numeric string and convert it into a numeric value, into int or double value. And so here's a formatting string using the format method. And now strings are immutable. In Java, we provide another class. It's called a string builder. You can create a string builder. It's the same. It's very much like string, but it's a mutable string. You have operations. You can change the contents. As string builder is very similar to string buffer, but string builder is the new class that's preferred way and to use mutable strings using string builder. All right, so you can see all these features, how to modify strings in string builder and using all these methods to get the properties from string builder and many others. All right, that is all for this chapter. Thinking objects. And so when you develop programs, you can think in objects. So this is object-oriented thinking. To design classes and creating objects, and the classes are related. So the relationship and all this, writing the code using object-oriented approach, writing reusable code. Thank you very much for watching. Goodbye.